Hello everybody, welcome to this vlog. My name is Satya. So today I will discuss the basics of home router, how it works using the whiteboard, where I'll explain in pictures or by drawing what exactly happens when a home router uses NAT, and in the future of the video I'll explain what is really the problem of NAT when you are making voice calls, when you have a peer-to-peer connection, or when you have a gaming session between two people who are connected to the game console from different places, right? So let me just start by introducing the home router, what exactly it is. So let's suppose this is the router box. So it has 1, 2, 3. Usually you will have 4 ports on the home router, which are called as LAN ports, which is a switch, right? And here you will have IP over E or DSL, or you have fiber, right? So usually, or the most important thing is it will have Wi-Fi access point. So these 4 ports which are given here are used to connect the desktop PCs, for example Windows desktop PCs or Linux machines, directly using a Ethernet cable to these ports, right? So the problem of using these ports is these are not mobilized, right? So if you have a DSL router or this home router somewhere at your home, somewhere in your home, then if you connect physically an Ethernet cable to these ports, you can't move that PC somewhere else. You need to move the home router also, which will disturb the Wi-Fi signal if other people like mobile devices or the laptops are using the Wi-Fi. So usually this will be used for an Linux or Windows machine where HTTP server or any hosting web applications are running in your home router. Then this is the WAN port, IPOE or wide area network port, which connects to the internet, right? So if this port is not there, then you will not get an internet connection. This port or this port, DSL or fiber. So you can ask me what exactly is the difference between IPOE WAN and the DSL or fiber port. These are the encapsulation or physical terminations in which they differ. IPOE is a pure IP port which is based on Ethernet, and DSL is based on a digital subscriber line, which is your normal telephone line, right? So RJ11 connector, and it works on PPPoE, point to point over Ethernet, and fiber has its own ways to connect to the internet. And also there is another way we can connect is through cable, right? So you have the cable which are called as coaxial, not I should say cable, like you have the set-top boxes where you use the cable connection, right? So such kind of cables can also be used as a physical terminator to connect to the internet. So today I will discuss about these 4 LAN ports, Wi-Fi, IPOE and the NAT, right? So let's suppose you have PC and a Wi-Fi is connected to laptop, right? So the PC is a Windows PC or Linux PC which is connected directly through the Ethernet cable to the one of the ports of this switch, LAN ports. So let's suppose you connect the PC, and as soon as it's connected to the LAN port, it will have two modes here. One is auto or manual. Most of the people would have seen these two options. So what is auto? Auto means you're acting like a DHCP client. Manual is you provide the IP address manually. Right? So, what is an IP address? IP address is a 32-bit identifier which identifies this PC, laptop, and different devices connected to this home router with a logical endpoint address. When I say logical, it's at the layer 3, and this is usually logical, right? The physical address, which is at the Ethernet layer, is more physical. So that is mapped to the vendor that supplies that particular port, right? So, or the Ethernet card vendor will have one physical address that he would have given to that port on the PC, and that PC simulates an IP stack or emulates an IP stack on top of the Ethernet port, and there you can have manual, and there you can define the IP address. It's a 32-bit identifier. So you can see that 2 to the power of 32, I don't remember the number, what exactly will the 2 to the power of 32 will result in, but usually it will be in billions of devices. But even the billion devices, we have exceeded the billion devices, right, in the market. So currently the IPv4 address shortage is going on, for which we can use NAT, network address translation, which I'll discuss in the future of this video, next in the video. Also IPv6, which is an next version of IPv4. So many people ask me, why not IPv5? Yes, IPv5 was there, but it was not released. So IPv6 is the more stable release of the successor of IPv4. So in IPv6 you have 128-bit unique address, 128-bit address. So it can have 2 to the power 128, which is huge, beyond imagination. So there won't be any address shortage in near time. So today in this class we will only focus about IPv4 address, which is represented as, for example, a private address 192.168.1.2. So if I give 192.168.1.2 address here manually, we don't know if this home router, which is the next hop who provides the internet connectivity, whether it is 192.168.1.2 or 2.1 or 2.3 something, so it can differ, right? So usually when we install home router, the technician will know what exactly the subnet that the LAN ports are mapped to, right? So you will not come to know. So usually giving an address manually at home router is not advisable. So what we need to use is, we need to use a method called as auto, which is called as DHCP client. So when a DHCP client is, when you connect your PC to this port, Windows PC or Linux PC, and your network card is configured to have auto, he starts a DHCP client process. What you will do is, you will send one message which is called as discover, DHCP discover. So that message, you may ask me, how will you know on which IP address or a physical Ethernet address he needs to send? That's quite simple. So when you don't know something, you need to tell everybody that whoever is in the room, For example, you are discussing about certain topic and you need some information. You don't know which person to ask for that information. Then you broadcast that information, telling that I want this information. Who has this? Who has that particular information? Then one of them will respond, whoever has that information. So in the same way, in the PC, the DHCP discover will be sent broadcast. It will be sent to a broadcast IP address which is represented as 255.255.255.255. All Fs, right? It is called as ff.ff.ff. Or it's a decimal representation, right? Sorry. So it has to, because I was talking about Ethernet, so it has to be 255.255.255.255. But the physical address, which I was telling, will be ff://ff://ff://ff://ff://ff. Physical addresses are 6 tuples. IP address is 4 tuple, right? 4 tuple is, it is separated by dot. The physical address, which is Ethernet address, is separated by colon. So you will send a DHCP discover to a broadcast address. It is received here on the home router. It tells that yes, it's a broadcast address. I need to check this. So we'll check it, and here we should have DHCP server. So he is the server on the LAN port, right? Here he is the server, DHCP server. He will say, yes, I have an IP address which I can offer, or we can discuss further, right? So what he will do, he will respond with DHCP offer. Usually DHCP offer will be sent unicast. So for example, your PC sent a DHCP discover with a certain source MAC address, right? And he said, I want an address as 192.168.1.2. So he sent it saying, I want 192.168.1.2, but your DHCP server should be configured to provide 192.168.1.x subnet. If it's not configured for that subnet, he will say the IP address that I can provide, your client IP address, that attribute will be there in DHCP offer. He will say, I want to give you 192.168.0.2 instead of 1.2. But all the communication in the LAN segment or any segment will happen on the MAC addresses, not on the IP address. Even though we represent the devices using IP address, the last hop, always it will be MAC address. So he sent with the source address, for example, 001122334455. He knows the source. So when he is sending the DHCP offer, he will just put the source that was received in discover in the offer destination MAC address, and he will reply to the PC, right? And he will say this is your client address, and the source IP address he will use as the DHCP server IP address, and destination IP address will be 192.168.0.2. He is telling that use this, but the DHCP client here on the PC is designed in such a way that you will look for a parameter called as your client IP address. That IP address will be configured here. That's, again, you say that's an offer, right? He's not the master saying that you need to use, or the boss of the home saying that this address you need to use, whether you like it or not. That's not how the network negotiation happens. As soon as the offer is received, the LAN PC will again ask for DHCP request. If he likes the offer that is being sent, depending upon the parsing of different parameters in DHCP offer, he will send DHCP request. That will be a unicast, because he already knows the server address, so he will send a unicast. He will not broadcast it at the time. Then finally he said, okay, I sent an offer already. I have already created a binding on the DHCP server for that address, which is 192.168.0.2. Then he will say DHCP hack, right? Acknowledgement, DHCP acknowledgement. Finally, it's once he receives the DHCP acknowledgement, it's sure that PC now can create a binding or whatever routing entries that is possible. So now, friends, what we understood from the discussion till now is when you are getting a home router installed, a technician will come to your home, install the home router, but it's better that you understand what is your home router is doing. So if you want to connect a PC which is hosting different web applications, so that your friends or your customers can access it, you need to have one PC connected to the LAN segment. It can be on the Wi-Fi also, but Ethernet is more stable than Wi-Fi. Wi-Fi has a lot of interference, that this and all, so packet loss will be there. So PC is connected to a direct LAN port is the best method to have your hosted applications. As I told, it should have auto, that is, it will work as a DHCP client. If you have manual, you don't know which IP address to configure, right? Because home router will not tell the IP address. You only give a Wi-Fi access point and its key, whatever the passphrase is there, password, he'll give the that one to you and you will connect through Wi-Fi. I will discuss Wi-Fi later, but here manually configuring is not required, right? Unless and until you know which segment your DHCP server or your home router is operating in. And the second thing is DHCP server will provide the router, uplink router address automatically. If it is your 192.168.0.2, usually it will be 192.168.0.1. The first IP address in the segment, network segment, will be your router address. So that will be sent as a default router in DHCP offer and DHCP hack. You take that and build a routing table. Now, when you are configuring your PC as manual, that router address will not be there. You need to manually create it. So then, okay, let me take this. There are two ways. So as I told, if it is a manual, the router address will not be there. So in order to connect to the internet or to the uplink home router, you need to have a routing entry in your PC, right, which is here. So that routing entry, for example, if you want to connect to 10.10.10.20, then you can define 10.0.0.0 255.0.0.0.0, right? And the router address, which is 192.168.0.1. That means to say that whenever you want to send an IP packet or an application packet to address 10.10.10.20, you need to use this as your uplink router. Now let's suppose you want to send to an IP address which is called as 20.0.0.0.0. What if you want to send a packet to 30.0.0.0? Like that, the list goes on. You can't keep on adding these entries into the routing table. For that, there is a easy solution that being developed, which is called as a default route. As soon as your DHCP ACK is received with an default router, it creates a routing entry for IPv4 0.0.0.0/0 and it points to 192.168.0.1. That means to say any address which is other than the local link, which is other than 192.168.0.x, send it to 192.168.0.1. He will take care of the rest. He will take care of routing the packet. So that is the most important thing. And other thing is DNS, right? So DNS is domain name server. DNS. So when you are giving or opening the websites or trying to do artificial intelligence agents, you don't give saying ChatGPT address as 120.30.40. Something, right? So you don't play with the numbers. You only give chatgpt.com or google.com or ndtv.com or bbc.co.uk. So like that you give the names. Now the names are not understood by the network stack that we are having in the PC. So what we will do, we need to convert those URLs, I call as uniform resource locator. That means these are defined, each web servers or websites are defined by a particular URL that needs to be translated into an IP address. That is done by a DNS server. For that, again PC acts like a DNS client. He sends a DNS query to the DNS server. Usually your home router is a DNS proxy and the DNS server will be in the internet, which is maintained by the ISP. Okay, so he provides an equivalent of that URL www.chatgpt.com. IP address is translated to, like for example, 120.100.30.40 for example. So this address is provided to the PC and PC will again start sending all the application packets over this address, right? So what we discussed till now is how to get an IP address automatically using DHCP client, how to get the URL that we are trying to access using your web browser into an IP address so that network stack understands it. And then the next point is IPOE, IP over Ethernet. So as we told, in the LAN ports we act as a DHCP server. On the WAN port, which is IPOE, we act as DHCP client here. So this home router will have two addresses. One is on the LAN side, because it's a router, right? We call it as a router. So router can have multiple interfaces and multiple IP addresses. So LAN port will have IP address as 192.168.0.1, but the WAN port we can't decide it. It's decided by the internet ISP provider. He has a DHCP server through which again the DHCP handshake will happen. It's called as DORA, discover, offer, request and hack. Then IPOE interface gets an IP address, right? For example, if that IP address is 200.201.13.14, if this is the IP address that was received on IPOE, how will the communication happen on the home router? Any packet that is sent from the PC here to the external world, he will send using 192.168.0.2. It comes here, but the IP address needs to be translated into this IP address before it's understood in the internet, because 192.168.0.2 is a private IP address. It can't be understood for routing in the internet. So he needs to convert it into 200 or 201.13.14, right? So that is called as NAT, which is called as network address translation. Now, there are different type of NATs: full cone NAT, symmetric NAT, restricted NAT. So we'll discuss this later, right? That's a different topic. But the problem we want to discuss today, what is the problem of NAT? So you have the NAT, right? He says, for example, you started a VoIP call using SIP, which is called as Session Initiation Protocol, which is an application layer for VoIP. There are different type of application protocols which to signal the calling party or called party. Calling party uses SIP to call called party. Then the negotiation happens. What are the codecs that we need to use for the actual packets that we send, voice packets? So all these negotiation happen, which I will discuss again in detail in future classes. But just remember, the VoIP call happens using SIP for signaling. Let's suppose they decided upon using 192.168.0.2 here, and there is another home router somewhere in your friend's house whom you called has 192. It's a private, right? So it can be same address, 168.0.2 again. Now both have the same address. So how will it be routed, right? So that's why we use NAT. But we negotiated 192.168.0.2 because the application is running on the end client, which is the PC. There, when you make a VoIP call, he knows only 192.168.0.2. He won't know what is the public IP address, which is 200.201.13.14. Right? How will we know? Because that's a security issue. Right? If some hacker comes and tries to know this public address, he may hack into our router and try to create all unnecessary problems. So that's why this will not be advertised. To solve this problem, before he sends a endpoint address, he will ask the predicted IP address that will be used by the NAT, right? That using stun, S-T-U-N, stun server. He has a prediction saying once you send a stun query, he will just forward it to the stun server. Stun server knows on which IP address he got it, and he responds saying use this address for your voice call. Then he puts it in the signaling VoIP SIP protocol saying this is my endpoint address, and that's how this and also your friend's home also does that, whether it's a VoIP call or it's a PSTN network, it depends, right? So now the real problem comes. What if the IP address is not the only thing that is changed? The port also changes. The transport layer port also changes. Then stun will not be able to tell, because for each communication he will create a new port, right? So each application layer, even if it's the same application, each session will have one port address. So how will stun will keep on sending a new port address for each communication. So again, the communication will not happen. That is called a symmetric NAT, where the IP address and the port both are changed. For that, we need to create some logic in the internet to have this communication. That I will discuss later. But this is the problem. Symmetric NATs will usually fail in VoIP calls and the gaming sessions also. For example, if you don't have the logic to overcome this problem in the Xbox or PlayStation devices, then you can't have the gaming session between two people at two different home routers. So that is the problem of NAT, right? So then in the class I discussed about why we can't have the websites hosted in your home router to be on a Wi-Fi device. Wi-Fi, as you know, has evolved over different over the years, and we are using currently 802. The IEEE standard that we use is 802.11, right? So there are different Wi-Fi standards. So currently we are using Wi-Fi 6, is the most marketed Wi-Fi protocol in the network. So Wi-Fi 7 is also coming. So they are telling always that the rate at which the packets are sent are increasing. So earlier it was in megabits per second for Wi-Fi clients to use the network. Now it is in gigabits per second. So the problem is not that. The problem is the interference. For example, you are in an apartment and your home router is very near to other home router, and they share the channel on 2.4 gigahertz. Then there will be interference, right? So if there is an interference, the packet that you transmit will collide with other packets, because you will not get the airtime, right? So if you don't get the airtime, then for sure your packet transmission speed will be reduced. Lesser the airtime, lesser will be the airtime. So to avoid that problems, also there are different techniques which I will discuss later in the future videos. This is the introduction video using the board. So we discussed a lot of things today. So to recap, we discussed about DHCP server on the home router on LAN side, DHCP client on the PC. We discussed about DHCP client on the IPOE interface, DHCP server on the internet. We discussed about DNS. We discussed about NAT. We discussed about Wi-Fi. Okay. So friends, this is what is the basics of home router. So we'll discuss in depth in future classes other things. Thank you.